Hi, today in this video we are going to see how we can make use of JDBC chat memory to store the chat history in case of relational databases. So earlier we had made tutorials related to how we can persist the chat history in case of in memory, which is RAM. Also we covered how we can make use of PostgreSQL to persist the chat history. In this tutorial we will mainly focus on the MariaDB. So before we can start with the implementation, I would like to cover one important thing related to chat memory. So when we work with relational databases and when we have to store the chat memory in case of relational databases, this is the class which is important, which is JDBC chat memory, which is implementing the chat memory interface, and it has three methods to work with the memory. Basically add method to store any new messages or create the new entry into the database, get method to retrieve the chat history, and clear method to clear the chat history based on the provided ID. So if you see, we have the three queries. Basically these are nothing but the insert, select and delete queries, based on which the entries are created, retrieved or delete from a particular table, and the name of the table is AI chat memory. So based on the conversation ID, whenever we interact with the LLM and we want to store the memory inside database, there is a concept of conversation ID. So based on the conversation ID, the chat history is maintained inside the database. So let's quickly understand our project structure. I have created one simple application using which we can work with the JDBC chat memory, and we have created two simple controller, one for single user application and one for the multi-user application. So let's start with the pom.xml. So here we have added simple dependencies like Spring Boot starter app, starter web to create the REST APIs, Spring AI starter model, OpenAI. This will be used to interact with the LLMs. In our case, we will be interacting with Google Gemini, which is OpenAI compatible. So that's why we have added OpenAI dependency. Then we are making use of Spring AI starter model chat memory JDBC. This is the dependency using which we are able to implement the JDBC chat memory implementation in our code base. Also the class that we have seen earlier, JDBC chat memory, is coming from this particular dependency only. Then we have Spring Boot starter data JPA, which provides the support for JPA and which makes the interaction with the database much easier. And then we have the MariaDB driver in order to establish or work with the MariaDB. And then we have the Spring AI BOM, which is responsible for managing the dependencies related to Spring AI. This was the quick intro regarding the pom.xml. Now we have application.yml. Here you can see, in order to work with MariaDB, we are making use of data source. It is establishing connection with the MariaDB, which is running on local, and the database is Spring AI. We are passing the username and password via environment variables while running our app, and we have specified the driver information. Then in order to work with the LLMs, we have added configuration. So here you can see we are passing the Gemini API key via environment variable, and in order to work with the Google Gemini, this is the host which we are making use of, and this is the endpoint which we will be calling, and the model which we will be making use of is Gemini 2.0. And at the very bottom we have the configuration related to the logging. This will be useful to log the queries that are getting executed behind the scenes, so we will come to this part at a later stage. Then we have the chat client config class. Basically, in order to interact with the LLM, we will have to make use of chat client. So this is where we are creating the chat client bean. But before that, we will understand we are also creating the bean of chat memory, since we are interacting with the MariaDB JDBC. MariaDB, we are making use of JDBC chat memory, and it is creating the JDBC chat memory based on the JDBC template that we have. Now the bean that we have created will be passed on to the chat client. So here you can see we are getting the chat memory, and while creating the chat client using builder, we are specifying this chat memory. Also we have one advisor, which is message chat memory advisor. This is basically this is responsible for managing the chat memory. Basically the user and the assistant messages, it is responsible for collecting that and also passing those messages to the AI. So all the memory related management is done by this particular advisor, message chat memory advisor. And the chat memory bean that we have created will be passed here, and using this we are creating the chat client. Now we have created two classes. I'll quickly explain one class at this stage, and we will cover the next controller later. So this is the simple JDBC chat memory controller. Basically this controller is useful if we are creating an app and we want to create an app for a particular single user. Basically when we want to share the chat context between multiple users, this is where it will be useful. So here you can see the base path as API chat, and then we are creating the three endpoints. First one is the chat endpoint, whose base path will remain the same, API chat, and it is a post endpoint which will accept some input from the user. We will pass this input to the chat client, and whatever message we will get, we will simply return it to the user. And behind the scenes, all the conversation will also be stored inside the MariaDB database. We will see that example when we will start our app. Then we have the history endpoint. This is just a simple get endpoint to see what all things are stored inside the chat memory. So in order to retrieve the data from chat memory, we need the conversation ID. So in case of single user application, by default the conversation ID which Spring uses is the this particular conversation ID, which is default. If we are creating the app for multiple user, then we will have to create separate conversation ID for each of the user. We will also see that. Then we have the delete endpoint, which is useful for clearing the memory which is stored for this particular conversation ID, which is default. Now we will start our application, but before that let's see, as you can see we have created the Spring AI database, and inside that if we refresh the table, currently no table exists inside this database Spring AI. Now when we start our application, AI Spring AI memory table will be created. So we will quickly see that when we refresh this. Here you can see AI underscore chat memory table is created, and if we look at the structure of this table, we have the conversation ID, wherein against each conversation ID the chat history will be stored. So for single user application, the conversation ID by default will be default. Then we have the content, which is nothing but the interaction that we are doing with the LLM, and also the responses that we are getting from LLM will be stored inside content. And type denotes the type of the user. So whatever message user will send, the type will be user, and whatever response that we will get from LLM, the type will be assistant. And timestamp denotes the timestamp at which the entry was created in the database. So initially if we see the content of this table, it will be empty. Here you can see all the rows are empty. Now we will call our single user controller endpoint. So first message that we are sending to the post endpoint, which is API chat, and I will say my name is Bunty Ragani. So we will get some response from LLM, and also this particular entry, which is my name is Bunty Ragani, and the response that we got from LLM is also stored inside the AI chat memory table. So now when we execute the select query, here you will see two rows will be populated. So here you can see conversation ID is default since we are working with single user application, and the content that we have sent and the response that we received is also mentioned here. My name is Bunty Ragani. This was this message was sent by user, and this is the response that we got from LLM, and it was sent by the assistant. and timestamp denotes the timestamp at which the entries were created. And now when we call the get endpoint, basically we are calling API chat history endpoint. You will see currently we have two messages which are coming from chat memory, and here you can see the message from user as well as from assistant. And then we have the delete endpoint. Before delete endpoint, I would like to showcase you one example. Now LLM remembers my name, so when I ask what's my name, so it will give me the correct answer because we have maintained the memory. So it is saying your name is Bunty Ragani. Now when I delete the memory, so here you can see now we will have 4 entries, initially 2, and the next 2 will come based on the conversation that we had recently. So what's my name, LLM provided the response. Now when we clear the memory, so this operation was successful. The entries from database will be deleted. So here you can see all entries are deleted. And now when I ask my name to the LLM, it will give an error stating I do not know you. So I have no memory of past conversation, I don't know your name. So this is how the context was getting maintained inside the database, and with the help of advisor, the memory, the user and the assistant messages were getting passed to the chat client, or we can say LLM. So this was the simple example regarding the single user application. Now coming to the multi-user controller. So basically the structure is same. It's just when we are working with multiple user, we have to create different conversation ID for each of the users. So here you can see we have the base path as API users, and then we have the post endpoint, which is in which inside the URL we are accepting the user ID, and based on this user ID we are creating a different conversation ID. So here you will see where from the URL we are reading the user ID, and then we are accepting some content from user, and inside the chat client we are passing this information about the conversation ID. So here you can see dot advisors, and here we are specifying chat memory conversation ID, and this is the user ID. What does this means is, for each of the user a separate conversation ID will be created, and based on that conversation ID the chat memory, or we can say messages, will be stored against that particular user ID. Then we have the same get endpoint and the delete endpoint. While retrieving the data from database, we are retrieving based on user ID. So let's say user ID 1 will have their own set of messages, user ID 2 will have their own set of messages. Similarly, in order to delete memory related to a particular user, we are deleting based on user ID, and we are accepting user IDs as an input from the end user. So let's jump to the postman, but before that we will see the current state of our table. It is empty. uh, Sorry, it contains 2 messages based on our last message after deleting the chat memory for a single user. um, let's start with the multi-user example. So we are calling this endpoint API user, and then we are calling the chat endpoint. Now we will work with 2 characters, Alice and Bob. So first Alice is calling our endpoint and stating my name is Alice. So we will get some greeting from the LLM, and the messages will be stored inside the chat memory table. So here you can see for Alice the conversation ID is Alice, and against that 2 messages are stored. So now uh, Bob will also come, and Bob will say hello, my name is Bob. So LLM will remember that as well. So hello Bob, it's nice to meet you, how can I help you today? So for Bob you will see the conversation ID Bob will be created, and against which 2 messages are stored. Now when Bob asks what's my name, LLM will provide the correct answer similarly. So since it has the context, now when we clear the memory for Bob and post which we will ask the LLM, it will say I do not know you, but before that let's see the entries. These two entries should be deleted. So here you can see entries for Bob are deleted. Now when we ask the LLM what's my name, it will simply say an error as an AI, I do not know your name. And now when Alice is asking the same question, we will get the correct answer because entries for Alice are not impacted, even though which means the separate conversations are getting maintained against each of the user. So this was regarding the simple user and multi-user example. Now coming back to this part wherein we have specified the logging. So here we have added two configuration basically to log the SQL queries that are getting executed behind the scenes and to log some values as well. So for example, let's see the current state of our table. So here we can see the few of the entries are maintained inside the table. Now when we ask the question what's my name, basically some select operations will be performed, and once we get the response, then two insert operations will also be performed, one for the user query and one for the response that LLM provided to us. So now I have executed the query. So when we see the logs for this particular, here you can see we are getting the we can see that the insert and the select operations are getting performed. Here you can see these while executing the query the value Alice was passed, and also we are retrieving the last 100 messages. So this is how we can see the queries are getting executed behind the scenes. Also I would like to showcase you one more thing. So when we started our app, the table was created on the fly, but if we are working with the database migration tools like Flyway, so we can disable the schema creation part at the startup, and we can create our own tables using the Flyway or the MariaDB Flyway and with the help of MariaDB script. So in order to disable the schema initialization, we can add this particular entry Spring AI chat memory initialize schema to false. Then we can make use of this particular insert query, which create table query which will basically create the table AI chat memory, and again it will create the table with four columns like conversation ID, content type, and the timestamp. So this was all regarding the JDBC chat memory with the MariaDB. I hope you found it useful, and also we have created the detailed blog wherein we have covered both the part Postgres and MariaDB, and the example that we discussed in this tutorial is also uploaded on GitHub. You can check out if you are interested. Yeah, so thank you.